Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics, Institute of Aeronautical Engineering. Today, the topic for discussion is Convolution Theorem. In detail, we are going to discuss about definition of Convolution Theorem, problems based on Convolution Theorem. Definition of Convolution Theorem. Now, here, f of t and g of t. Two functions are there. The function f of t and g of t, they are expressed in terms of the variable t, where the t is positive. That's what mathematically it is written, t is greater than 0. Here f of t, g of t, they are connected by a small star. That is the product. How we have to read this one? Yep, the product of the two functions f of t and g of t, it's nothing but f of u into g of t minus u, and we have to do the integration with respect to u, and the values we have to take the integral, the value, the range from 0 to t. This is the definition of the formula related to convolution theorem. Based on this, we will solve a problem using convolution theorem. The question is, using convolution theorem, find L inverse of 1 by s plus a into s plus b. Looking at this problem, if it is only L inverse of 1 by s plus a, if the question is only this one, it is very easy, because the formula which is available, that is L of e power minus at, it's nothing but 1 by s plus a. So e power minus at equal to L inverse of 1 by s plus a. Here this L is playing a role of Laplace transform operator. The same here, L inverse is playing the role of inverse Laplace operator. If it is a single term, the question, it is very easy. But it is combined to one more function also it is there. That is 1 by s plus a. Another one is 1 by s plus b. And strictly in this problem, they are solved by using this convolution theorem. That means this formula to be used while solving this problem. So many ways are there to solve this problem. But if it is, they are asked strictly to use this particular problem by this method. So we are forced, we have to apply this convolution theorem formula while solving in this problem. Now the solution we will concentrate. Now the question which is combined and given 1 by s plus a into s plus b. This is the question it is given. In this one particular part, we are assuming as f bar of s. Another part, we are assuming as g bar of s. Then f of t, because we know the formula, why we have to do these steps? Because we have to apply the convolution theorem formula. In the formula, the left side, which plays the role, the product of f of t and g of t. So to apply that theorem formula, f of t into g of t, it is required, it is must, we want it. So we want f of t. F of t, it's nothing but L inverse of f bar of s. Simple way, this L inverse of f bar of s, how we got it? That is, we know it. L of f of t, it's nothing but f bar of s. So f of t, it's nothing, L inverse of f bar of s. So one particular part from our question that we assumed f bar of s, that f bar of s, we are finding inverse Laplace transform with the help of inverse Laplace operator. L inverse is the inverse Laplace operator. With the help, we are going to find f of t. So L inverse of 1 by s plus a, it's nothing but e power minus at. This is the elementary function formula. The next one is, so the question what we have to do it. So g bar of s, 1 by s plus a, that particular part, we are finding L inverse. We are applying inverse Laplace operator to this g bar of s. After applying, the result is nothing but g of t. So L inverse of 1 by s plus b. This is already 1 by s plus a. Here plus a is there. That is the reason the result e power minus at. Here plus b is there. The similar manner, it's very easy thing we can e power minus bt. Now L inverse of 1 by s plus a into s plus b. This is only our given question. So to apply it, this particular part we have taken into this part we have taken. Mathematically it is correct. So we are going to apply now this convolution theorem. That is the product of the star, how we can read it. The product of f of t and g of t, it's nothing but f of u into g of t minus u. And we have to do the integration with respect to u from the integral 0 to t. Already we got it. That is f of t. Just now in the previous slide it was explained. F of t we got it e power minus at we got it. But we want it f of u we want it. So wherever t, we have to change the particular t to be changed in terms of u. So f of u equal to e power minus au. Fine. Our first target is completed. Yeah, we did. Then g of t. This is also already we found e power minus bt. But we want it g of t minus u we want it. But here only t is there. The meaning is wherever t, we have to put or we have to change that t in terms of t minus u. Yeah, fine. We will change it. T minus u e power minus b of t minus u. This is very important thing because here the careless mistake, the room will be given here. So t place we are substituting. That means minus b of the bracket is very important. If you miss this bracket, because minus b is common to t minus u. If you miss this bracket, it leads to careless mistake. The entire problem, we can't reach the destination of the correct result. So now, so f of u is ready. G of t minus u is also ready. We calculated and weighed it. We are going to substitute in this particular place. So we substituted. This is f of u. This is g of t minus u. Here we are going to do small simplifications. That is e power minus bt into e power This minus b minus u, it's nothing but bu. Just we brought this, we have taken minus b inside the bracket. We did the multiplication. Now, this integration is completely with respect to u we are concentrating. So, this minus e power minus bt is nowhere connected to this integration part while doing the integration. So, it is treated as constant. That is the reason the front of the integral we put it. Which one we are going to do? Integration. Those terms are inside the integral. So, e power minus bt into e power minus au, that is, this term it is written as it is. In this which is treated as constant, it is front of the integral. Before the integral we put it. The remaining part, it is related to u. That is why we have to do the integration. It is kept here. du. Next, this step it is written as it is. This e power m into a power n exponential law. This we studied in lower class itself. So we have to do a power m plus n. Obeying this exponential law, here our terms are, this is according to exponential law, what is the variables are used, I wrote it. Here, that we will apply in our given problem. That is e power minus au, this one, plus bu. So, e power minus is common. In this both the terms, u is there common. We have taken the balance, we put it. We can check it the next step. This step, we can cross check it. We have to get the previous step. Then we are moving in a correct path. So, e power minus a, yeah, fine. Minus into minus plus. We can recheck it to avoid the careless mistakes. Yeah, fine. Now, up to here, we completed. This part, we have to do the integration. Very simple integration. E power minus x is there. What is the integral? E power minus x, e power minus x with respect to x. In general, I am telling. In general, I am explaining e power minus x is e power minus x. But what about the x coefficient? That we should not forget. The x coefficient. Very simple way. They are asking about coefficient of x. Leave x. The remaining is minus 1 divided by minus 1. That's what the difference between integration and differentiation. If it is differentiation, multiple it will come the coefficient. But we are doing integration. So divided by minus 1. So next we can concentrate how the integration is taking place. Here e power minus bt. This part e power completely what is given. E power minus of a minus b into u as it is written. U, the coefficient. Why we are stressing u? Because we are stressing on the variable u because we are doing the integration with respect to u. Then coefficient of u, leave u. The remaining is minus of a minus b. Fine. Then 0 to t. Now we will do more. Any simplifications are possible. If you do, then totally there won't be any room for committing mistakes while solving the mathematical problems. So now what we have done it, the minus we kept it to the previous slide. So we can notice that here this part and this part nowhere it's because in terms of u place we are going to substitute these limits. So remaining others and all we can make it outside. So that's what it is written here, outside. The balance, the remaining part is e power minus of a minus b into u 0 to t. here, this here minus is there. E power minus bt. Here minus we have taken. This minus cancel. That's what this term we got it. We are applying in terms of u. So the first here this place we are substituting. So e power minus of a minus b t. And what about this minus? It is nowhere connected to our problem. It is connected to formula minus, that is upper limit minus lower one. So the lower one is 0. So e power 0, the value is 1. So it is written here 1. So now next step, this e power minus bt is there. So we are taking inside e power, this term I am writing, minus bt, e power, this one, minus at, into e power bt. This term, combining, we are getting e power 0. The leftover is this term, that's what it is written here. The next, this term and 1 we will multiply, same as it is we are getting. So we completed the first problem using convolution theorem formula. One more problem we will concentrate. That is, using convolution theorem, evaluate L inverse of 1 by s square plus a square the whole square. So now here the question is L inverse of 1 by s square plus a square the whole square. This problem can be, we can write it s square plus a square into 1 by s square plus a square. Because we know the convolution theorem formula, the product of f of t into g of t. So we need f of t. If we need f of t, it's our requirement is f of t, then f of t it's nothing but L inverse of f bar of s. So we are forced to, the part of our problem we are taking as f bar of s. Fine. Another part we are taking g bar of s. Next, f of t it's nothing but L inverse of f bar of s. So L inverse of this, a part of the problem, 1 by s square plus a square. Here suddenly we got this answer. That is, we apply it. This L inverse, it's nothing but inverse Laplace operator. That we applied this function, we got this result. But how we got it suddenly? Because the elementary functions, some standard formulas are there for the Laplace transform. That is, L of sin at, it's nothing but a by s square plus a square. This how we got it? Again we have to go back to Laplace transform formula. That is Laplace L of f of t, it's nothing but integral 0 to infinity f of t is multiplied by e power minus st dt. This f of t is playing the role of sin at. Substituting, integrating, we will be getting this formula. Some standard formulas, sin at, that is a by s square plus a square. Now this L of sin at, this L we will push it here. Then sin at equal to L inverse of a by s square plus a square. Fine. But here, which is missing? 1 by s square plus a square is there. But here a is there. Here a plus 1 is there. A is not there. A is missing. Then mathematically we have to obey some laws. Suddenly I can't write here a. Because the question will come the next doubt. Suddenly how it has come a. we have to balance the equation. We have to obey the mathematical laws. So here I want to multiply a, we have to balance, then we will put it divide by a. So multiply and divide by a we did. So this is becoming this 1 by a. Now it completely, it is on the format of our given formula, that is the elementary function of sine a t. Inverse Laplace operator applying, that is L inverse of a by s square plus a square. It's nothing but sine a t. That's what it is written here. Fine. Next, g bar of s. Now g of t is there. L inverse of g bar of s. Now L inverse of 1 by s square plus a square. The same one, 1 by a into sine a t. So this is our given problem. It is written once again. So 1 by s square plus a square into 1 by s square plus a square. Why we are following these steps? Because in the problem strictly it is told, solve the problem by using this convolution theorem formula. According to that, we wanted f of t, the product of f of t into g of t. That is the reason the given problem also splitting, we are writing in two functions. So now L inverse of f bar of s, that is 1 by s square plus a square. G bar of s, same thing, 1 by s square plus a square. It's nothing but the product of f of t and g of t. Fine. Now the convolution theorem we can take it. So now f of u is there. G of t minus u is there. Here du, with respect to u we have to do the integration from 0 to t. We got it. That is f of t we got 1 by a sine a t we got it. That is in terms of t we got. According to convolution theorem formula, f of u is there. So the t wherever it is there, it should be replaced to the variable u. That's what it is written here. 1 by a into sine a u. The next one, g of t, also the same, 1 by a sine a t. Here also, we don't want in terms of t. Here we want it in terms of t minus u. So, 1 by a sine a we are not going to touch. That is the reason sine a is written a only. We are going to touch only t. In the place of t, we will write t minus u. Because g of t, we wanted g of t minus u. T is replaced, t is changed into t minus u. So, 1 by a sine a of t minus u. Here we can see it. It is written clearly. Now, 1 by a, 1 by a. Put together 1 by a square. Fine. We have to do the integration. Now our target is, we have to do this integration. To do the integration, if it is only integral of sine, it is there. So integral of sine, we will know it, minus cos, we will do it. Simply we will come out. But here we are facing the problem. What is the difficulty we are facing? Because here only one trigonometric function is not there. two trigonometric functions, sine AU, another one is sine A of t minus u. A single trigonometry, it is very, very easy, but two are there. Is there any relevant trigonometric formula which make us our integration in a very easy way? The same if we keep, we can't reach the destination of results. We will make ourselves while solving the problem more complicated, confusion, everything will come. So, the two trigonometric functions are there. Both are, one is sine AU, another one is sine A of t minus u. Relevant. What is the trigonometric formula? This is not only in this problem. Anywhere, two trigonometric functions under multiplication, they are dominating the relevant trigonometric formula to be applied. So now we can see it here. This is 1 by a, put together 1 by a square, fine. Suddenly here 1, 2 it is occurred, that is divided by 2 is there. It is not possible. Suddenly anything we can't, if you multiply, the corresponding division should be there. If you add anything, corresponding subtraction should be there to balance the equations. Only adding it is there. It is mathematically, it is wrong. So here divided by 2 is there. Here multiply also should be there. So now we can see it here. The corresponding actually the trigonometric formula what we have taken. 2 sine A sine B, it's nothing but cos of A minus B minus cos A plus B. This is the corresponding the trigonometric formula what we have taken. With this help, we are going to do this integration. Why we did this multiply and divide by 2? Because this trigonometric formula, it is 2 sine A sine B. Our problem only sine AU, sine of, that is sine A of t minus u is there. 2 is missing, that is the reason multiply and divide by 2 we did. The first point is now very clear. Now, with this trigonometric formula, we will compare with our problem. In the trigonometric formula, A is there, the capital A is there. What about our capital A in our problem? In our problem, our capital A is AU. This picture, this point, it should be very clear to us. What about B? Here is there, AT minus AU. Now we will substitute our A. This is formula, capital A, ours is AU. B, it's nothing but AT minus AU. This is very, very clear now. We will substitute. This is 1 by 2a square is written as it is cos A. Our A is AU. Fine. What about B? B here minus B. We want minus B. So minus of B is AT minus AU. Simplify, minus AT plus AU. So now this 2 AU minus AT. So the first one, cos of A minus B, we completed. This minus is as it is. Next, cos of A plus B. Our A is AU plus B, AT minus AU. This getting cancelled. The balance is cos AT. Now we have to do the integral. It is very easy now. The integral. Before the integral, they are connected by the mathematical operation multiplication. Now the integral, they are connected by the operation minus symbol is there. Because mathematics, we know it, the operations, plus and minus, depending on, we will count to the terms. Here first term, here second term. So they are single terms now. It is very easy to do the integration. To do this, This step we want it. We make our integration in a very easy manner. That is the reason this trigonometric formula we applied it. This is the reason behind this applying this trigonometric formula. Yeah, fine. Now 1 by 2a square. This is cos integral, sine, cos of some term, because the trigonometric function cos is expressed 2au minus at. First cos, we will write it 2au minus at divided by, we are doing the integration. Usually we know it cos x. Immediately we will tell, yeah, the integral is sin x. Everybody we will be telling. More it is there. Cos x integral sin x. What about the x coefficient? X coefficient is 1. That is divided by 1. This we should not forget. Sin x by 1 equal to 1. Sin x by 1 equal to sin x. The similar manner here, the cos the integral is cos of some term. So sin of 2au minus at divided by coefficient of u. The coefficient of u, it should be divided by. Why divided by? Because we are concentrating integration. So divided by the coefficient, it should be written. Next, here minus cos at. We are doing the integration with respect to u. So the complete this is treated as constant. So du, integral du, it's nothing but u. That's what it is written, u. Now 0 to t, we have to apply. Our upper limit is t, the lower one is 0. Now this 1 by 2a square. The upper limit is t. That means in the place of u, we will apply t. So when we are applying this 1 by 2a, it is written as it is sine of 2at minus at. So 2at minus at, it's nothing but sine at. Here this minus is as it is, cos at as it is, u place we applied t. So the upper limit, that is t, in place of u, we substituted and we got this result, that is 1 by 2a into sine at minus t cos at. What about this sign? This sign is related to our problem? Nowhere. It is related to the formula, the limit. That is upper limit, we applied it, minus formula minus. Now this part, it's nothing but the lower one is in the place of u, we are going to substitute the value 0. So we will substitute now. Here u place we are substituting. So this is written as it is. This is the formula minus, we got it. Here sine of 0 minus at we are getting divided by 2a. This part will 0 into anything, 0. Here sine of minus at by 2a. This 2a it is there. Here sine of minus theta. It's nothing but minus sine theta. Trigonometric formulas, we have to be very, very careful. That is a sine of minus theta, it's nothing but minus sine theta. Because of that, due to that, this sine is playing a role here. Now 1 by 2a square, 1 by a sine at. So now we can see it here. This is 1 by 2a. Here 1 by 2a sine at. This is minus t cos at. Here we are applying 2a square Just LCM we have taken AT cos AT divided by A. This A again here joining here, it has become 2A cube. So now sin AT minus AT cos AT. Yeah, we will come to a conclusion of this topic, conclusion theorem. First, what is the definition of conclusion theorem formula? That is f of t, the product of f of t and g of t. It's nothing but this f of t is expressed in terms of f of u. This g of t is expressed in terms of g of t minus u, and we will do the integration with respect to u from 0 to t. And we concentrated a problem L inverse of 1 by s plus a into s plus b. This first treated as f bar of s. The second part we treated as g bar of s, from which we obtained the result f of t and g of t, the similar f of t. And we did the integration in terms of u, we converted that f of t. This g bar of s, from which we obtained g of t, that is expressed in terms of u, in terms of g of t minus u, and we did the integration. Another one, that is L inverse of 1 by s square plus a square, the whole square we did here also, but here we applied the trigonometric formula, two functions. One is sin at, another one is sin at minus, now we can see it here. So another one is sin AU, another one is sin of AT minus AU. So the both the functions we got it, then we applied the corresponding trigonometric formula and we solved it. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.